this field moves very fast. I started thinking about OFAs at labs about a year ago, and this was just on layer ones. And since then, there's been a big push for trading moving to layer twos, and the dynamics are changing a little bit for layer twos. But I think the ideas that I'll share with you today all hold. Okay, so this is the rough outline of what I'm going to talk about. I'm going to talk about what is the problem to which OFAs claim to be the solution to. I'm going to talk about how do these crypto OFAs work. So again, it's just going to go a little deeper into things that Julian talked about, but I'm going to focus on it from the user's perspective because I work at Uniswap Labs, which not only does the sort of AMM thing that everyone knows about, but also focuses a lot on the user and like retail users. And then the third and fourth points are more of like research directions and questions, open problems. And one of them, question 3, do they work, is something that Mishin and CMAC tried to look at recently in one of our papers. And I'm going to mention what problems arise, which Andreas kind of mentioned in his talk, where he talked about cream skimming. But I'm just going to like double click on that a little bit to let you know that we are aware of this problem and it's an open problem, and would love if someone in here thinks about it more. Okay, so I have to start with MEV. And I really love how CMAC introduced MEV, saved me a lot of time in having to go through what I think MEV is. Because MEV before, which stood for minor extractable value, has now been used today to refer to as maximal extractable value. But it's no longer within the block itself, on the blockchain. As CMAC mentioned, there's intrinsic and extrinsic MEV. But I want to take this one step further. And when you first, if you're not in the crypto space and people are just passing around the term MEV all the time, I think it's clearer to just use the word EV, extractable value, because it's not really ever the maximum amount of extractable value. All I care about is was value extracted from the trade. So that's just, I prefer to think about it as extractable value if it's the first time you're hearing about this term. Okay, so again, spherical cow. This is a block. For those of you who don't know, a block is just a list of transactions, an ordered list of transactions. And now you're a user and you want your transaction to end up in the next block. But the problem is that you're not sophisticated enough to get that transaction into the next block. So what you do is that you put your transaction into this public mempool, where it's now open to a bunch of sophisticated people who can get your transaction into the next block. And I draw this person here with dollar signs in their eyes, because they're the people who will put your transaction into the next block. And they're incentivized to do so because they can make money by doing so, right? So it's incentive compatible. But the problem is that in putting your transaction into the next block, they also pocket a lot of money, right? And this is the problem we're trying to solve. And this leads us to this notion of extractable value. In the sense, your trade or your swap or some transaction you wanted to add to the blockchain had some extractable value associated with it, right? So in some sense, you as the user created this extractable value, because if you did not create this transaction, the value would not exist. Now the problem is that and if we look at this extractable value pie, right, how much extractable value exists, it gets broken up and distributed amongst, I drew this person as an abstraction for these different players. They like searchers, fillers, whatever you want to call them, block builders, the validator. They capture all of that extractable value. But I just said you as the user created that value, right? So wouldn't it?
What are the searchers doing, please?
I'll get to that. It's okay if you don't, just put in a black box for now. Yeah, so the problem is that I said you as a user created that value, but you cannot capture some of that value. And we would like to return some of that value to you, right? The user who created this value. And how do we do that? Order flow auctions. Okay, so that's my view of why we need order flow auctions. Oh, what is the problem order flow auctions claim to solve? Any questions? Feel free to interrupt at any time. Yeah.
Would you say the user created the value? I think of the value coming from the interaction of the user's order with other orders, and they're changing the order, priorities, whatever. So it's not quite like as one user, I created value, but there is value to be made from sequencing them differently or whatever.
Yeah. I agree. Like
that is important. It may not be important for your audience.
Yeah. No, I agree with you. It's just a different way of looking at it from the user's perspective that in some sense the opportunity to reorganize the transactions wouldn't exist if my transaction wasn't there. Yeah. Yeah. Okay, so a high level of, again, try to keep it high level, is that these order flow auctions sort of auction off the right to extract value. And when I was learning this, I said I don't do auction theory or game theory or anything. So I Googled what are auctions used for, and it says like price discovery. So I think, what are we trying to discover here in this context with auctions? And I think the thing we're trying to discover is the amount of that extractable value that we can return to the user and still get the transaction onto the blockchain. So in some sense, people are saying, then the system needs to be incentive compatible. You need basically to pay them to get your transaction to the blockchain. But we can recapture some of that value, and we're using auctions to discover how much of that value we can recapture. Okay, so again, just if you're hearing about, well, I guess nobody here should be hearing about order flow auctions for the first time, but I like to think about it as literally, you're putting an auction on the order flow from the user onto these group of people that I'll describe in a moment, these searchers, fillers, solvers. And the ones that I'm going to talk about today, I think maybe this audience is not fully aware with, because I don't think there are degen traders in this audience. But there's Uniswap X, Uniswap Classic, 1inch Fusion, 1inch Aggregator, CowSwap, MEV Blocker, MEV Share, and the list goes on. But they all work in very similar ways. And I just want to sort of dig into how these work a little bit more today. So my focus is going to be on this side, like what the user interacts with, and not sort of like the auctions that occur from the block builder and so forth. Okay, so the easiest way to split up those set of order flow auctions is to talk about transactions and intents. And I know intents is a word, for this audience, it's just orders, but somehow the crypto community has rebranded it to be intents. So we'll get there in a second. Transaction. So this is how I like to think about transactions. It's from a quantum mechanics meme that I really liked. But so let's say you're a user and you have some token A, right? And you want to swap token A for token B. So what is a transaction? In the context of the crypto economy, or like on-chain things, what I'm doing is I'm sending some instructions to the Ethereum virtual machine, and I'm telling it to trade token A to token B, go through this Uniswap pool, and that Uniswap pool, for example, I'm basically specifying the path that you want to take. That is the transaction in this case. So for those of you who know, it's a call data. I'm defining the path, right? That's the transaction. Any questions about that? Okay. So you can think about order flow auctions for transactions in this way. They essentially sort of cashback auctions. So what you're going to do is you're going to put your transaction, which is your call data. You have a question, Fahad? Yeah.
So actually, I thought you were drawing a distinction between intents and transactions.
Oh, I'll get to the intents in a sec.
So
Yeah,
wonderful action for the transaction or for the intent?
for the transaction. Yeah. So you basically, yeah,
Transaction, I thought you've already specified the entire sort of path.
yes.
So
You still need to auction it off. Yeah. Because for example,
I'm
yeah.
saying like from Uniswap X, like I put in an intent.
Oh, this is not Uniswap X, but
No, but just
yeah,
as an example, so then
Yeah.
that's not what you're talking. You're not talking about like.
this wouldn't classify Uniswap X. This would be Uniswap Classic.
What you're thinking about is coming up. So
Yeah.
Yeah.
Yeah. So exactly, you specify the path that you're going to take. It's not like a private market maker or something, or at least in the context I'm talking about now. It's saying go through Uniswap, go to this specific pool, put in this amount of token with this amount of slippage tolerance, and you could hop to another pool if you want, but all of that is specified in the call data already. Yeah, go for it. Go ahead. Yeah.
Before Uniswap,
Before Uniswap, you say Uniswap Classic, you mean before Uniswap X existed, but the
Yeah.
same front end interface, right?
Yes.
So on the front end interface, I would just say something like, hey, I want to buy 1 unit of ETH, and it's going to tell me how much USDC or whatever I have to pay for it.
Yeah.
And it's going to do a router. It's going to try to figure out what the optimal chain is.
Exactly. Yeah.
But so what is the, like, where is the auction coming from? Meaning, like, I think about like, so when I say I want to buy 1 ETH, that's an intent, right? If I say I want to buy 1 ETH
Yeah.
or X amount of USDC, that's an intent. That's not a transaction.
Yes.
At that point, though, I tell the interface that, and
Yeah.
it does a routing and comes up with the exact transaction, which you're alluding to.
Yes.
Right?
Yeah.
But so what is the step there that is the auction?
Oh, because you didn't try to get your transaction on chain yet.
Yeah, well, once I click the button, now the
Right.
call data is going to be sent.
Right. So then you can choose if you want your transaction to go to a public mempool, or you can connect to something like MEVShare or MEVBlocker.
Do that on Uniswap Classic?
Yeah, if you use like MetaMask or something to connect to RPC, things like that. Yeah.
Okay.
Yeah, I'll get to that. Cool. Okay. But when you already specify the path, the main point is that your auction is working like a cashback system. Because as I said, you specify the path, and these people they can. So these are the searchers now. Searchers, fillers, solvers. We can call them whatever we want, but they're the people who deal with the user's transaction or intent. In this case, just transaction. And for example, they see that Fahad wants to trade USDC for Pepe, and going through Uniswap pool, and they say, oh, there's actually an opportunity to make money off of that trade and off of that exact path. So I'm going to bid money to get that so I can make money off of it. And the person who wins is the person who's willing to give the most cash back. And the examples of the OFAs that work like this are MEVShare, MEVBlocker, and BackRunMe. Because, well, I'll get into why it's called BackRunMe. But again, this is how they all work. They just compete to put your transaction on chain, and then the person who gives the most cashback wins, and the user receives cashback and feels happy because they know that they got a redistribution of the extractable value that they're creating. I'm going to go into this a little bit more for those of you who are a little more curious. So this is how they all work at a high level. So you have the originator, which is the user, and they send their transaction to the OFA. So, MEVShare, BackRunMe, whatever. And then they have a network of fillers. And again, these fillers, searchers, solvers, they're all like the same word of representing people trying to extract value from users. It's just like, just treat them all the same. And they're all competing to, fill this user's transaction. So what's happening here is that the OFA will sort of broadcast some aspects of the user's transactions. And the fillers will create these things called bundles, right? So I have a set of transactions here, like, for example, parentheses, underscore T2, T3, and they'll have a bid. And filler B will send another bundle with a bid. filler C will set another bundle with a bid. And they'll send all of these things to the OFA. And the OFA will then have to put the user's transaction in that spot because they don't want to reveal all the information to the fillers. So the OFA then puts that transaction into that spot and broadcasts it to the block builders. So in this sense, okay, what's happening? The thing that's being auctioned. So first of all, who are the participants of the auction? Well, the buyer is a block builder because a block builder is the person who gets the bid, right? The seller are the fillers, right? Because the fillers are trying to sell their bundles to the block builder. And the thing that's being auctioned is a bundle containing the user's transaction. Is that clear? Is that too technical? Or is that too simple?
Can you explain filler again, right?
Yeah.
Like the
Oh.
technology keeps on changing, like I've been
Oh.
using Uniswap V2 since it got deployed. And
Oh, as I said, think about filler as just the person who's willing to, or the person who sees, the person who wants to extract the value from your transaction directly through routing or private market making.
so are
and-
these the citadels of blockchain?
Not, well, right now I'm just using this term generally, and I'll show you, I'll answer that. It can be them, but it doesn't have to be them. They can be using Uniswap pools, for example, to,
And so is
Yeah.
T2, T3 in curly brackets?
Yeah.
Is that a block?
no, that's a bundle. So it's a small set of transactions that they are hoping will be included into the block. And why is it a bundle? Let me just go to that. Why is it a bundle? Why is this thing working? Because one of the benefits of this OFA is that you can, what they call programmatically enforce no front running by ensuring that the user's transaction is placed first in the bundle. So that way you can only be back run, for example, within this bundle, you can only be back run, and you hopefully will get some of the profits from that back run.
So can you tell us, you first had this very nice thing for a block. You said the block was T1.
Yeah, right.
Could you write us what the block would be compared
Yeah.
to T2, T3?
So it would be, you take that T1, Tn, and in that block, you just pull out 3 random ordered transactions, and you're like, oh, maybe that's the bundle that existed.
And the fillers, are they saying something about where in the block those transactions will be ranked?
They only, this is a good thing. What they order the transaction here in the block, they don't have control of where it's ordered. And there's a trust assumption here that when your bundle gets put into the block, that the block builder didn't rip apart the bundle and do things to it.
What is the constraint that the block builder must respect? And that takes into account the curly bracket T2, T3.
The constraint that they,
How does
Yeah.
T2, T3 constrains the block builder?
I would say it doesn't, this is where the trust assumption is coming in. And
Bundle stays together.
yeah, you're hoping that the bundle stays together.
The block builder doesn't have to adhere to anything other than valid state transmission.
Yeah. But I think
Change.
you can choose not to send your transactions to some block builder if you believe that they're going to rip apart your transactions.
Hold on.
Your bundle.
Yeah, wanted to ask a question first.
So what could the same outcome be achieved if Ethereum would allow negative fees? Then I could post a negative fee put it in the public mempool, wait for somebody else to pick my transaction up, send it as a bundle together with a positive fee to the block builder, so that the average fee would compensate the block builder, but I would get my share back in terms of a negative fee.
Yeah, I think in theory that, you're saying that the rebate is equivalent to a negative fee, but I think Ethereum has a different usage for their fee structure, which is to prevent congestion, things like that. So yeah, does that make sense? I think Ethereum, as Julian said, they're not concerned with the application layer also. So I think from their perspective, the gas is a congestion mechanism, and it's up to the applications to figure out how to deal with the MEV after. Yeah.
Okay.
Oh,
Yeah,
sorry. Who
sorry.
should I? Okay.
So yeah, I'm still a bit like confused about like what the information is being exchanged and what is being withheld,
Yeah.
because one would imagine that in a kind of standard case, so one's wanting to extract values, they might get ideas based on what they see. But what you are saying here is that in the auction, you are seeing some information which you don't know. So how can you be the, I mean, yeah, what do they know and what like
Yeah. So I don't want to get
being withheld from them, like
yeah.
intuitively, right?
Okay, yeah. So just to add, if you go on any of these guys' websites and you try to understand what's going on, it's a little confusing, including our website sometimes. And so they all act in different ways. So I can't make a exact statement, but I can make a general statement, and that especially Flashbots with their MEV share is that they have something that they call programmable privacy, and they allow the user to pick what they want to share with the searchers and with these group of people, the fillers and the searchers. Yeah.
Oh yeah, not a question, just a general comments
Please.
to answer some questions. So like there is actually a fair market rule that's enforced by Flashbots in the circle with the block builder that they should not unbundle the bundles from a searcher. And like usually the searcher will be the first one like shouting in Twitter and like disclose if they feel like their bundle is getting, you know, front rounded by the block builder. And another comment to someone raised the point about like negative gas fee. Like it's not a module right now in the protocol, but it's like a constant idea like brought up by people like called fee escalator, where I think you can't really do it right now like by putting a negative gas fee right now in Ethereum, but you could realize it by sending order flow to some like gas refund kind of program like Flashbots is also experimenting right now, and get like higher refund than your gas fee paid, which effectively you're getting negative fee.
Wait, can I move on, because you might have more questions for the other things. I would like to move on.
It's one more, yes.
Question. So, so now I'm just like, again, just to clarify.
Yeah. Yeah.
Clarification.
Yeah, totally.
Like not the same page.
Okay, perfect.
So, on hand, you say originator, so like has one transaction.
Yes. Yeah.
All the pillars, then they have like, then you're talking about the bundle of transactions.
Yes.
So, and the cashback.
Yes.
So is it correct? Like, would it be correct to say that, so there is one originator, or like lots of originators, then these pillars, they solve the problem. Like if I take a bundle of this transaction, somehow they extract the value, and then they think about it and they say, okay, so based on whatever I can extract, I can offer like this specific originator this cash back.
Yeah.
Okay.
Yeah.
So, and then to that, so there should be several originators basically.
Yes.
Left-hand side.
Yeah.
So
I'm just thinking about one user.
bundles.
Yes.
And
But only one originator's transaction can be in the bundle. That's one downside of it. It cannot manage batches right now.
okay.
Yeah. So yeah, every bundle will just have one. Let me just repeat that. Every bundle will just have one user's transaction, because this is one of the downsides of mechanisms like this, is that if the bundle had many users' transactions, it would be unclear how to redistribute the hashback to those group of people. So in the interest, yeah.
Sort of in this interaction, right? It's sort of implicit that the builder will maintain the order together.
Yeah, it's implicit that, yeah, but they will take the bundle with the highest bid. That's what you're assuming.
But the bid is to the originator here, right?
No, so the OFA manages the process, and the bid is to the originator and the user. Sorry, the user and the block builder, but it's the block builder who will decide at the end of the day if to include the bundle, because the block builder will take the highest bid. And what's happening is that a fraction of the bid will go back to the user, and a fraction will go to the block builder. Yeah, sorry, I put like a 1 minus F and then a F. Sorry. Yeah, I didn't. Too many questions. Yeah.
No, just a comment. Like, so I work at Cow Protocol. We run both the intent auction with CowSwap.
I'll get to CowSwap.
And we also run the MVP blocker. And so
Yes,
I'm
I know.
involved in the design of both.
Yeah.
I've designed the fee mechanism. I wrote the rules that builders have to follow. I wrote the documentation, which is quite clear. It's not
Oh,
that
the
it's
MEV
less.
show-
No, there are 1, 2, 3, 4 rules that builders have to follow.
Yeah, the MEV blocker one is extremely clear. And
Thank you.
yeah.
And one thing that I think is important is that the mechanism relies on builders following some rules. And the threat from the OFA originator is that if, first of all, most builders are bounded, so they can be can take the money as to repay whatever damage they cause. And but the real threat is the disconnect from the order flow, which and you lose these transactions that are private. So then you have a cost in terms of losing blocks in the block building auction. And so what is important is that a lot of these steps are really delegated to the builder. For example, typically the builder receives several bundles for each transactions, and it's up to the builder to select the bundle that gives the highest rebate to the user, or multiple bundles, because a single transaction might have multiple bundles if the first one doesn't fully exhaust the rebate opportunity. And so this is all delegated to the builders and verified ex post. And if we see that doesn't behave as it should, either it's like some money is taken from the bond or perhaps even disconnected. So the security here is really relying on the explicit rules from the OFA, order flow auction operators that can punish the builder.
Yeah. Okay. I might get some more comments from you soon, because I'm going to talk about call swap in specific. Okay, so intents. This is, I think, the way to view intents, and in the sense that you're a user with some token A and you want some token B, but this time I close my eyes in the middle because I don't care how you get me that token B. And that means, what's that? Yeah, sorry. In some sense, you don't care what happens. Any path, you can take any path, and I'll get into what that means, any path. But so this is, I think, what is familiar for orders in this audience. Okay, so to get into what this any path can be, so you have the swapper on the left side, the filler on the right, and from the swapper's perspective, you're only going to see sending token A and receiving token B. And the filler can choose to fill your order from a variety of sources. So they can either use what I like to refer to as like private on-chain liquidity. So some people call this off-chain liquidity, but I think that's confusing if you, I guess if you don't know, is that the liquidity exists on the blockchain. It's on someone's address, and they're just choosing to transfer you money from that address. And so this is what people would group as private market makers. So maybe that's your question about like Citadels and the Jane Streets and things like that. They would be on that side. And then we have the filler can also choose to use public on-chain liquidity, which is what I just use public and private. But that would be grouped as all the AMMs and everything that's publicly available in an AMM. So yes, that's part of your filler question too. It's anybody who's doing that to fill your order. And just to give you an example, this is some transactions from Uniswap X, where when the user doesn't specify how they want their order filled, and they just say, fill me my order, on the left here is the filler. So this is, if you take this transaction hash, put in either scan, pull out the logs, and hand draw, trace them like me, you'll see this is the user. The user is trading ape for USDC. And the filler does some kind of complicated route and gives the user the USDC that they want. This is another example where the trader, the swappers on this side, and they're trading WETH for 1-inch token. And the filler uses a bunch of on-chain liquidity sources to do some complicated route and give the user back 1-inch. And this is the example that a lot of people don't like. We can get into that, where the filler just says, hey, you want USDC for link? I'll just give it to you directly without going through any type of public liquidity or AMM or anything like that. Okay, so okay, call swap. So might get some questions. So how do intent auctions work from the user standpoint? So the user goes to the OFA, like Fahad was saying, and say, I just want to trade A for B. Tell me how much B I'm going to get, right? what happens is that these group of fillers are sort of doing their own calculation, calculating their own routes, private, public inventory, a mixture of both. And they're all, telling the OFA, I'm willing to give you this much token B. And the point here is that I put the most amount of token B is the one who wins the auction, which is different from the previous case where it was the most amount of cash back that won. So it's kind of the same, it's like paying for shipping or free shipping. But when it says free shipping, the price is in there already. And that's what's happening here. Everything is internalized. That'll happen along the way. And the user is just getting the sort of final cost. And everything is internalized. And the person who is willing to give the most amount of token B is the one that wins. I just have to check some notes on this. And one thing I wanted to mention is that these auctions are only restricted to swaps, whereas previous auctions are open to any type of transaction. And a pro of this is that you can handle batch auctions like CowSwap, which I'll get into. But in the previous case, you couldn't handle batch auctions. Any questions? This is a high level one. I'll probably get attacked in the next one. No question? Yeah, please. Yeah.
Sort of timing.
Yeah.
So what I'm thinking of right now is like Uniswap X, when it goes through the RFQ.
I'll get into that
auction.
detail in a second.
But so you're including cases here where sort of in some sense the bid is not necessarily enforceable, right? Like I'm saying the RFQ winning bid, Uniswap X, is not necessarily a price that I'm going to get if I go through the whole process.
Yes, it's
which I'm distinguishing that from the case
true.
where where there's a
Good
bid
point.
and it's like somehow like that they can't fade on me.
Right,
Or it's somehow directly settled or something.
It's so I guess it's a person who promises the most B.
Yeah, promises.
Yeah. No, but actually when when the auction occurs, I take that back. When the auction actually occurs, and I'll explain it in the Dutch auction, it is the person who ends up giving the most amount of token B that wins.
No, sure, but it doesn't happen at the same time, right? So
it doesn't happen.
Because then you get into a totally different issue. Like,
yeah,
maybe the price moved and that's why they're filling it, right?
Yes, yeah. But this is you're right, and we'll get into that in more detail. That's for layer 1 on Ethereum. But when these things are going on layer 2 soon, and then your answer is that.
Was that a Unichain plug?
No, on Arbitrum, Optimism, things like that. And then it's going to be literally the first person to fill wins.
Okay.
Yeah. Okay.
So can I?
Yeah. I know you have a comment about Uniswap X, but I'll get to your comment after.
No. I actually just trying to figure. So just to be clear, so Uniswap X here is, or CowSwap, they are running the auction, right?
Mm-hmm.
So is there, I mean, maybe you're coming to this, but is there any concern about information leakage, which is what we would normally have? So this goes back to Joel's point. He actually didn't make so much, but Citadel made a very nice submission in their description of the order flow auctions, which is like, oh, why don't we just wait for the customer order to come in? We kill everything at the ask, and then we can just charge them whatever we want. Right. So I'm paraphrasing now, but this is essentially a worry that could be here the case, right?
There is some information leakage, but I don't want to get into the details of how exactly Uniswap Labs front end works, but I do think that we have ways to reduce it. I don't know if Shin, can you answer that later? So I can.
I said that offline.
Okay. Yeah. I don't want to say it publicly. Okay, so moving forward, there's one other distinction between CowSwap and Uniswap X and One Infusion, and is that CowSwap uses batch auctions, right? So this is not the CowSwap AMM. This is just like the intent OFA that they have. And so again, just my silly diagrams on Uniswap X and One Infusion, a single intent is auctioned off to a network of fillers who are trying to compete for that single intent. But in CowSwap, the users, what happens is that multiple users come with multiple different intents, and CowSwap will create a batch. And now the thing that they're auctioning is this batch of intents. And the fillers are competing to fill this batch of intents, right? And then the one that wins will put the, well, basically, yeah, the one that wins, the CowSwap has a some sort of function that you need to maximize to be declared the winner. I don't want to get into the details. What I said is correct, like roughly correct, right? Okay, cool. But and yeah, so some function that they're optimizing to win the batch. And one thing good about like why does this work from why do users like it is that how does it make sense for a user to use maybe is that CowSwap offers this thing called uniform clearing price. So if you have a bunch of transactions in this batch, so it can be A to B, B to A to C, like E to F, or a bunch of these random things. It just ensures that there's a uniform clearing price within this batch. And in doing so, you sort of reduce, to use CMX term, the intrinsic MEV. So by definition, there's no intrinsic MEV within that batch because everyone got the same price. So no matter how you reorg or anything, like within that batch, you have the same price. That doesn't say that you don't have extrinsic MEV. And in addition, when those transactions get added to the blockchain, it doesn't mean that within that block, there isn't intrinsic MEV. That's all I wanted to say about CowSwap. Okay, cool. Okay, so little detail about how Uniswap X works because I think.
For the last part.
Yeah.
You said within the block, there could be intrinsic MEV within the transactions.
No, not within the transaction. The transactions always have the uniform clearing price, but someone else in that block could have gotten a better price than you if they use Uniswap. Just kidding. I was just kidding.
They started late.
Okay, perfect. Okay, I can speed through. Should I go through this? Maybe, yeah, I think it's important. Okay, so just to let people know how Uniswap front end works a little bit is that when a user comes to the interface, we have internally this Uniswap router, which is going to check the Uniswap pools. And then I'm a little worried people are taking pictures of this. And we have some external group of coders who are providing codes for this order. And then an algorithm determines, for example, if the Uniswap quote is higher than the quotas, then we instantly create the call data, or if the user wants to carry out the transaction, create the call data, and the user can choose to send it to a public or private mempool. The second step, if the quotas provide a higher price, is that we use this information to parameterize the Dutch auction by ourselves. So this is still within the Uniswap, like Uniswap Labs section. Everything is off-chain still. And then these fillers see this Dutch auction and they compete to fill this Dutch auction. First person who fills it wins. And then the fillers will create their call data and send it to the public or private mempool. And just to finish up the Uniswap X piece, there's also an on-chain component of the Uniswap X protocol. And so the fillers who choose to fill through that Dutch auction, the Uniswap X protocol manages the on-chain settlement of this system. So the fillers can choose to say, oh, I want to fill with my private inventory, or I want to pick some complicated route like I showed you before. And they can also fill against other users. And it's all of that's parameterized in the Dutch auction and in the call data that the fillers use. And then the on-chain protocol ensures that all the user sees is the swapping of token A for token B, and everything else is abstracted. Okay, just to remind you, there's a kind of dichotomy that occurs depending on which path you take. And all of this is to ensure that the user gets the best price, is that if you go to Uniswap X, you can get access to all these liquidity sources, right? As I said, private on-chain, other users, you can get batch with other users, you can get other protocols, you can get the Uniswap protocol. But if you get sent to Uniswap Classic, then you only have access to the Uniswap protocol. And I'll get to your comment soon. Yeah. Okay, so I just want to get into the research piece, just to let you know what we're thinking about, and hopefully what other people can think about in this room. So I mentioned we have OFAs. OFAs claim to be the solution to a particular problem. I just described to you how they work. They all work in different ways, claiming to do different things. And they all, have marketing that makes it confusing from a user's perspective, including Uniswap, which will say, we give you the best price, MEV protection, no MEV, whatever. And it's a little confusing which one of these is true, which one is the best, right? And the best in this case, I think someone mentioned it, theoretically best is different from practically best. And as I was showing you how these systems work, no? I'm a theorist, and it's been hard for me to accept that too. It's so many things are going on. You have users, you have fillers. If your fillers aren't as good as like somebody else's fillers, it means that your prices will be worse, regardless of how good mechanism you have. So I guess what me, Shin, and CMAC were thinking about recently was how to actually empirically see which of these are the best, So we wrote this paper, Quantifying Price Improvement in Order Flow Auctions. And let me describe to you a little bit about how we approach this problem. So the problem is that you have crypto trades occurring and on these different order flow auctions, ending up on chain, using different systems like the person who's willing to give you the most token B, or is it a cashback system? And we want to make some empirical evaluation of how good is like Uniswap X versus One Infusion or something like that. I just use that because that's the example we use. And because they all work in different ways, we need a sort of standard way of looking at them. And the way that we choose to solve this problem is kind of similar to if I asked you, how would you compare two mountains, right? All the mountains are kind of similar, but they're in different parts of the Earth. And the thing that you would be naturally led to say is height above sea level. And I colored this word blue, and what color is that? Purple, for a specific reason. Because height is kind of like, your metric or your dimension or your axis, and sea level is like your reference point or your baseline. And what we choose to do is measure something called price improvement compared to Uniswap Classic. Okay, so just to recap, problem, how to compare, and our solution is price improvement compared to Uniswap Classic. And we can literally write this down as a super basic formula, is that I take the all-in price. So this is like if you get cash back, I include that in the price. I recalculate it. Basically the price net of everything. And I compare it to some counterfactual price on the Uniswap interface, sorry, the Uniswap AMM, so the Uniswap protocol.
Not the centralized Binance, right? You
No.
don't to do the cloud.
Just to the AMM, yeah.
Don't do the traditional microstructure exercise like event-driven, the centralized exchange.
Oh, actually, I forgot a point. Good question. Why do we have to do this? I forgot to motivate why we have to do this. The problem is you have all these types of assets, and you can say, oh, let me just compare to a Binance price or a SEX price or something, right? Problem is like most of these assets aren't on a SEX, so how are you going to compare the price? Someone else told me, oh, well, you can compare all the prices within a block at least, because at least if someone from Uniswap got a worse price in a block compared to someone from 1inch, then you can make a statement about Uniswap giving worse price than 1inch. Problem is that there's a very small overlap amongst blocks, right? So you have to come up with a way to kind of like universally bring all of these to one baseline if you want to make some kind of comparison. That answer your question?
Yeah.
Yeah, okay, cool. Yes.
You mentioned that Uniswap X references the classic prices.
Yeah.
So you're already bounded below by classic.
Yeah, I'll show you that.
So maybe.
Yeah, we'll see that. Okay. Oh, this is perfect right here. So this is high level results. All I want you to do is focus on the. So first of all, on the y-axis is this price improvement compared to Uniswap Classic metric that we talked about. And on the x-axis is this sort of settlement compared to your block time. So just focus on the line going through 0, which means I'm measuring price improvement at the executed block, right? So this is all I want you to focus on. Anything else, don't worry. You can read the paper if you want. And as you mentioned before, well, first of all, let's talk about this. I'll get to your question. You can see that the trades going through Uniswap X and 1inch Fusion have some non-zero price improvement. That's one of the main points, right? And on the right-hand side is sort of the aggregated version of both. If you compare to Uniswap, if you group Uniswap and 1inch into one, you can see, read along the zero line, you can see the price improvement of both interfaces. Okay, to get to your point, I like to think about it in this way, where you have precision and accuracy. And one thing is that when we were going to measure this, measure a quantity, I tried to think about things in this context. And accuracy was something that was a little hard to achieve. And when I say accuracy, I mean the difference from the true value. And the problem is that in real life, if you go to measure something, you don't know where the true value is. So how do you how can you be confident that you got a measurement that's close to your true value? Well, you have to test your assumptions. And one assumption, if you go back to go back here. If you go back to my definition of price improvement, it's a price improvement compared to Uniswap Classic. So if I look at this metric and I look at Uniswap Classic and I can see what the price improvement is, it should be 0, right? So, well, within this error bar, it's 0. So that was sort of like an accuracy. So people, there are even things to discuss within this analysis, but the main point is that on average, this thing accurately says that the price improvement of Uniswap Classic with respect to itself is 0. So on average, I think it's a good result. 2 minutes? Okay. Skip through this. Oh, actually, one interesting thing that we wanted to ask is, okay, what are they doing to get this price improvement? And to get price improvement, you really only have 3 things you can do. You can play with liquidity, so how much output token I'm willing to give back. You can play with the gas fees. The gas bid and priority fee and sorry, I'm forgetting. It's base fee. No, not the pool fee. Priority fee, yeah, and the gas fees. Okay. And I'm just running through this super quickly because I have a few minutes. What we do is take a Taylor series approach where I'm just looking for a linear approximation or like a first order approximation of what's happening. And then we can actually decompose these price improvements into different components and learn that, for example, Uniswap X and 1inch Fusion, which are these intent-based systems that sort of can access more liquidity. It's actually showing that the assumption is that they can access more liquidity by aggregating, and whether it's like real or private, and it is achieving all of this, most of the price improvement through getting through accessing more liquidity. And just to hit Andrea's comment about marginal versus equilibrium, some research from, this is this old slide, some research from Brian and other people here, they found that sort of, the cream skimming thing you were talking about does lead to increased spreads on the AMM, not just from Uniswap X, but somehow from 1inch Fusion. Well, not also 1inch Fusion, but somehow in a different way, which is a little confusing. But one problem that we're trying to solve is that in a world where we operate a front end and our competitors are accessing liquidity from different sources, we also want to be competitive. So we also have to access liquidity from different sources. And that gives us a positive marginal improvement, but it could be hurting the equilibrium. And it's still a problem, an open problem of how this will play out, at least on layer 1, which some people say is not where this should happen anyways, like trading shouldn't occur. But that's it from me.